Welcome to CyberOptics here at IPC Apex. Delighted to be joined by Dr. Subodh Kulkarni. Nice to see you again, Subodh.
Good to see you, Trevor.
Yeah. So, we're going to cover a couple of topics about your products. But I mean, first of all, I want to talk generally about what's happening with the convergence in the industry between back-end packaging and traditional SMT. We're starting to see more and more of it. What are you seeing out there?
Absolutely. We are definitely seeing a convergence of the packaging, semiconductor advanced packaging area with SMT. And that whole general area is being referred to as advanced packaging. Clearly what is driving it is things like stacking of chips and fan-in and fan-out packages. Once you start taking, the semiconductor industry is struggling to shrink the transistor in 2 dimensions, the classic Moore's law, and every generation is getting more and more expensive. But suddenly, about a few years ago, the semiconductor industry discovered that there is a third dimension to take advantage of, the Z-axis. And once they found out that it is possible to thin down chips and stack them, and the value you get is huge compared to the complexity of the stack, now that whole third dimension is exploding, and suddenly skyscrapers are being built by the chip industry. And that has led to an explosion of advanced packaging applications. And inspection is critical over there, because once you start stacking, you are essentially dealing with extremely thin chips, and any distortion is a huge problem.
Exactly.
So they need to inspect each and every bump or pillar, which is essentially the glue between the stacks. And that has led to an explosion of need for inspection, 3D inspection in advanced packaging area. And it's overlapping with SMT. I mean, if you take a look at the latest smartphone, iPhone for instance, and open it up, you don't find a conventional PCB in it anymore. It is mostly advanced packages that are strung together with some kind of a flexible substrate. And that's exactly how the industry is evolving. So I definitely see the convergence happening right in your pocket right now with iPhone or Galaxy devices, and that's not going to go back. So in future, more and more of our advanced electronics is going to be with advanced packages, and SMT and Semi is finally merging. It's called advanced packaging.
Right. Well, we've been, as I said to you before, we've been waiting for this for a long time as well. Now, you've got a foot in both camps, of course, because you've got a semiconductor division as well as a traditional SMTA division. Is some of your technologies that you're developing in the semiconductor side filtering down into SMT?
Absolutely. So what we are focused here is what we call MRS technology, multi-reflection separation. It's a unique way of doing 3D non-contact optical sensing that we pioneered a few years ago. And it is much faster and more accurate than many other conventional older technologies that some of our competitors are using, like Moire pattern, those kinds of technologies. So with MRS, it's a digital technology. It's a multi-projector, multi-camera digital technology. And the really secret sauce we have is the mathematical algorithms that give us the speed and accuracy. With that, we first got into semiconductor industry with partnership with KLA, who's a big player in the semiconductor inspection. And that's how we started commercializing MRS in the semiconductor industry, with a partnership with the KLA's back-end business unit called ICOS. And at the same time, we commercialized our SQ3000 3D AOI system on the SMT side. Over time, what has happened is, with our knowledge of what back-end needs and the merge of SME and SMT, clearly we have targeted what we now call a multifunctional SQ3000 system. So it does SPI, AOI, as well as coordinate measuring machine. So it's really an inline CMM tool. And it's with the better resolutions we are getting, we are beginning to approach the back end, or what is the advanced packaging area. So it's an exciting time for us to be taking advantage of our semiconductor legacy as well as our SMT legacy and play in this space right now.
I mean, metrology is becoming more and more important in the SMT space, not just for being able to measure packages, but especially for the auto programming.
Absolutely. Auto programming is here to stay. People want it. And metrology is a critical part that enables, and you need it. So auto programming is not only needed for time savings, but also to eliminate any human errors or variations. And metrology is a key part. People just don't want a pass-fail report anymore. They want to see the actual numbers to make sure that the pass-fail report has some substance behind it. And if something is failing, they need to know what exactly to go and change. They don't want it just to know that it has failed. And without measurement, you are kidding yourself to think.
They've got to be able to also digitize that information for the traceability and to work with the Industry 4.0 systems that are coming out into the market.
Correct, and there is the whole AI suite that is beginning to come along in Industry 4.0, and AI needs hard data. AI doesn't just need pass-fail, and for hard data they need measurements and they need exact variances and accuracies and stuff like that, and that's where AI tools become more effective. So I think it's all coming together at the right time to lead to better yields and productivity.
Now, one of the areas that CyberOptics has been pretty well known for and pretty famous for really over its history has been its sensor development. What is happening in the latest end of your sensor development?
Some exciting things going on in our MRS technology development. I mean, as I said, MRS stands for multi-reflection separation. It's a unique way of doing 3D non-contact optical sensing that enables us to get better accuracies and speed at the same time compared to conventional technologies. Now we have commercialized what I call the second generation MRS, so we call it the nano MRS technology, and we have developed not only higher resolution, so now we are down to a 3 micron sensor with MRS pixel size, but in addition we also have capability to measure perfectly reflective surfaces like silicon wafer or mirror like surfaces, because we can take care of the specular angles as well. On the show floor here we have a 3 micron 2D sensor, MRS sensor, that we are showing our customers, and we are getting tremendous interest. We have actually sold a few units already of that 3 micron 2D sensor.
Really?
And pretty soon you will see us talking about 3 micron 3D with specular dimensions, and by the end of this year you will see our 3D AOI SPI platform capable of handling perfectly reflective surfaces with better resolution than what you have right now.
It's scary the sizes that you're getting down to, the dimensions you're getting down to now. 3 microns is nothing. It's unbelievable.
Human hair is 80 micron in diameter, so we are talking some seriously small dimensions here. But that's what you need in the advanced packaging world, because the bumps are 30 to 40 microns each, and the pitch is about the same. And to measure 30 to 40 micron features accurately with good resolution, you do need a 3 micron kind of a resolution.
Well, it's fantastic to see how you're developing these things and staying ahead of the trend. Dr. Kulkarni, I want to thank you for joining us today.
Well, thank you for your interest, and we look forward to updating you with more exciting announcements soon.
Yeah, thank you.